it will activate. It's going to lose that heat sensor, I'll show you that in a minute, and it's going to spray water in that pattern right over here. It has nothing to do with that one, or that one, any of those. This is individual. And if that one gets hot, then that one's going to do it. Okay? But the majority of fires that have sprinkler systems in the room are controlled by one sprinkler head. 95%, one sprinkler head. Okay? 98% are controlled by two sprinkler heads. So very rarely do we get a fire that sets off more than two sprinkler heads. Keep going. Yeah. All right. So when we fix spray nozzles, open sprinklers with no heat responsive element can be encountered, especially in deluge systems. Talk about that. ESFR sprinkler, talk about that. All right. So a typical sprinkler head anatomy. All right. So you can tell by looking if it is a pendant, hangs down like a pendant on a necklace, upright, sits on top of a branch line, or sidewall. So if you go to a hotel or motel and you open the door, you probably will notice on that wall you just entered, there is a sidewall sprinkler head. Okay, a little deflector across the top, because there's really no need to get the concrete floor wet. Concrete's pretty non-combustible. So we're going to put a little deflector there, which is going to spray the water into a useful area, not an unuseful area. And then the next door and the next door and the next door all have the same configuration. They're all kind of designed about the same. So again, this is an upright because of the umbrella shape to the sprinkler head. This also is upright because of the shape of the, actually not, deflector. My bad, deflector is what the water hits. This one is a pendant. It hangs down and that just breaks up the pattern from a solid stream to the umbrella shape. It does not turn it 180 degrees like those do. All it does is hit it and break it. And ESFR, an ESFR can put out up to 100 gallons a minute. So really pretty impressive when you look at these. It's an expensive sprinkler head. It's a specialized system. I only have one of these bad boys. Maybe that's mine. Look at the size of this bad boy. You got one of those? Anyone? All right. So orifice opening. This is designed for a moderate hazard, light hazard. It'll put out 15 gallons-ish per minute. This will put out 100 gallons per minute-ish. So high hazard. Yes. Respond to heat, cap or plug open, water is discharged. So, the ones that you're seeing right now have a cap over this, just a little metal piece, and that keeps the water at bay. And it is held at bay through this middle part that's missing on this one. But all of these other sprinkler heads have a middle part. Look up, you can see it. Okay, it's between these two things. These are called the frame arms. This and this. That's a deflector. Frame arms. That makes up the structure of your sprinkler. All of the stuff in the middle is a heat collector. And it will collect heat up to a point, and at a certain temperature, that middle part fails. Okay, and if you look at your sprinkler, you will probably see a temperature on there. This one I don't see it, but it should be somewhere. But instead of spending too much time, this one says SSU, standard sprinkler. It's been rated. U upright, P pendant, S sidewall. So SSS, standard sprinkler sidewall. SSP pendant, SSU upright. Here is what a sidewall might look like. Again, no need to wet the ceiling. It's concrete. So this is gonna hang, you come into your room, and this sits here, and it's gonna spread water here, 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 all the way out there, covering your room, nothing really up to the ceiling. Sprinkler rated according to the temperature at which they're designed to operate. We can color code, so there's a liquid in these. Yeah, see that little vial in there? That's got a red colored liquid in it. The red tells us approximate temperature that it's going to go off at. Okay, but it's rated for a standard, so all office-ish type buildings are going to be rated for somewhere in there. But there's a certain number rating where the color, you can either paint the frame arms or you can look at the liquid inside of there. So liquid, what happens when liquid heats up? It expands. Okay, and that's going to break the glass, and that's how you get the middle of that one out of there. The ones that we're passing around, some of them are heat-sensitive strips that they will fail and bend out of the way, and when they bend, they fall out, and the water will come out and hit it. Other ones are fusible link. On one of them, it's got a temperature, I'm sure, right on that fusible link. Don't prove me wrong here. It's going to prove me, no, it isn't. 165. You can see it right here on the fusible link itself. At 165, this will melt, fall out of the way, and then these arms are going to collapse under the pressure of the water. Question?
What would happen if an object hit a sprinkler head? Would it activate it?
Yep. So if we were running along in a high-low here, and we hit that, it would break. And what's behind that? Water. It would come out. Look it up on YouTube. You will find it. They're funny. They throw out a lot of water. So it's got to be appropriate. If this were a warehouse and there were high-lows going back and forth, what type of orientation of sprinkler head would you want? Upright, because it sits above the branch line. So they can hit the branch line, and that'll take a little bit of a hit, but they're not going to knock off a sprinkler head. That's good.
Depending on the building, is what type of sprinkler head that you would want to adjust? Like you would want to put in, depends on the building.
Yeah, occupancy tells you the temperature rating and the orientation of the sprinkler head. But be careful, because you said adjust. Sprinkler heads are not adjustable. Okay, we sell a variety of them, 150, 155, 160, 165. Based on your hazard, we can give you whatever you want. But there are not adjustments on sprinkler heads. All right, so color, frame arm, or stamped for the sprinkler ratings when they go off. So again, here's some of the things you're seeing. Fusible link, that's the one I just pointed out, and on there is going to say the temperature. It'll also say SSU, P, or S in this case. Frangible bulb heats up the liquid, it breaks. This one's a chemical pellet, so this arm and this arm are made of two separate alloys that are going to twist in opposite directions. So it'll just cause it to fail and move out of the way. You can see that the frangible bulb has a red liquid in it. You can see the frame arms here are painted red. Sprinkler deflectors are attached to the frame arms. They create the discharge pattern. We talked about that. Common sprinkler orientation, so there's an upright one. You can tell by the umbrella shape. Deflector, pendant, you can tell it just looks like a gear shape. Sidewall has that flat piece on it. They do have recessed or flush. Flush sits even, so high-low's not going to hit it, or carrying boxes or any of that type of stuff. Concealed. So this concealed sprinkler head sits back flush here, and then we put this little plastic cap on this, but it's all part of a rated system. This plastic piece will fit over that so you don't see a sprinkler at all. But it is designed to melt. If your sprinkler head is 155, your plastic is 145. It will melt out of the way sooner than the sprinkler head goes off. So that melts at 145. By the time it hits 155, your sprinkler head is going to do exactly what it was designed to do. And you'll find those in fancy places like Caesar's Casino in Las Vegas. They want, look like Michelangelo's painting. So they don't want sprinkler heads sticking out of that. So they have sprinklers because it's required, but they have them with the concealed, and they painted right over them so you can hardly tell in some cases. But again, they're gonna fade away 10 degrees minimum before it operates. Sprinkler storage. There is going to be a sprinkler storage cabinet, usually where your main control valve is in the sprinkler room. You're going to have a minimum of one type of sprinkler head that's found in the occupancy. So if this room has these heads, there's got to be at least one of those in there. And let's say another room has a higher temperature head near the flammable liquid storage or something like that, then we're going to have one of those in there. And if we have one in our ice cream area of the building that has its own head for its own temperature, we're going to have one of those in there. So minimum of one of every type of head in there. Absolute minimum is 6. And then you can see a wrench here. The wrench is to replace sprinkler heads, but we don't replace sprinkler heads. Maybe if you're in the most remote part of the country, you replace sprinkler heads when they go off, but there's liability, there's leaks, there's drips, there's pressure tests, there's stuff that we don't do. So we typically, same as the board ups, we don't do that stuff. Okay? We can plug sprinklers. We've got a couple options on that, but we don't replace them. Control valves equipped on every sprinkler system so you can stop the water. Make sure that when we stop it, we should have, this is in a perfect world, we're going to have one firefighter that we send to the main control valve. And their job is to make sure that that system stays open as long as we need it and until we have the fire controlled. And then we're going to radio for you to go ahead and shut the system off. And that is all going to be you. Don't let anyone else from the business in there and say, oh, we need to do this or that or the other thing. Nope. Indicating. Okay, so there's a picture of your OS&Y, outside screw and yoke, outside semi-yoke. Again, blocker plate here attached to a screw. They're both pulled up, the water flows behind that. If that threaded part goes down, so does the blocker plate. You will not see the thread. That means it is closed. So hopefully just during maintenance or something like that, that would ever happen. But that's what you would have to do. Sometimes you'll see these chains on there. Is that going to stop you?
No.
You should all be saying, absolutely not. I know many ways to overcome that chain, so from very simple to very complex. We do allow that so people don't tamper with it, because sometimes these wall post indicators are on the outside wall of a building. So that's all teenagers and skateboards and stuff like that. Okay, so people can tamper with that, which is why this is on there. It's called the tamper switch. If anyone messes with the valve, then it sends a supervisory signal that there's a problem. Okay, so if you've ever been in an enclosed stairwell and you turn that valve, it's going to send a supervisory signal that someone's tampered with it. So that's not going to necessarily evacuate the building and sound an alarm. It's going to notify maintenance that something needs to be serviced. Okay, we don't want to evacuate the building because somebody twisted a valve.
Does it only have to be water in the sprinkler system? Like if there's a floor solvent leak that catches fire?
There can be foam systems as well. Yep. All right. Wall post indicator valve, there's a window, as is the post indicator valve. There's a window, open shut or open closed are the words that are going to appear there. Just like the OS&Y, see that little wrench here? Okay, and that valve there, if you turn it, guess what? You're doing the same thing with the blocker plate, moving it up or moving it down. So that's the same thing. Post indicator valve is just a butterfly valve. It just opens 90 degrees. Okay, so if you turn, oh no, it might have, in this one, it's attached to a mechanical advantage. So like a hydrant thing. If you turn it and you get this yellow part to block this, and it lines up, then it's blocked. If you have it this way, then it's open. So you can kind of see, hard to see two-dimensional, but that's what we're looking for there. Alarm test valve tests the alarm. Inspectors inspects to make sure the alarm goes through and water flows through. Main drain to drain it so you can service the system. Water supply, you have to have a water source, you have to have a decent amount of pressure. If you don't have it, you have to have a fire pump. Fire pumps, when there's not enough pressure, then you have to have a fire pump to build up pressure in the system. Fire pumps run automatic, so just like a home generator. Who's got a home generator at home? Okay, a bunch of us. All right, so a bunch of you, not me. But anyways, the generator will run on its own as a test once a month or something like that for a 10-minute period. Make sure everything works. Same thing with the fire pump. It will run on its own. Make sure everything works. And then there's a way we can shut that automatic function off if we need to service it. And there's a way we can test it. Okay, put it under a load. And so when we look at the outside of the buildings, you know what an FDC looks like. Okay? If you see strange connections, or if a male hose does not go to it, or then look at it, and there's a valve on top of it, open-close valve, and it says pump test header, that's not the FDC. The FDC is probably next to it. Okay, so make sure you know the difference between a pump test header and the FDC. That's what tests the water flowing out of the pump when we need to do that. Right, I think I have a picture at the end. Fire pump right here. Different sizes for different building sizes. Okay, we have a small one here, which I will show you at some point. Fire department connections. Obviously, we know that the standard is a Siamese. 2 males go to feed the Siamese. There's a clapper valve, so you can feed one side at a time. Goes into the building and feeds the system. If the system does not need that water and just one sprinkler head is going, it's going to sit just like the water behind that faucet right there. It's sitting there, static. It's not doing anything, but it's there. McLaren, open that valve up for the water. Turn the water on. Yep, there it is. Shut it off. Still sitting there. Okay, so that's exactly what happens when you put water into an FDC. It sits there. If it needs it, it'll use it. What are you supplying? Volume and pressure. If it needs either of those or both, it will take them. If not, it sits there just like the water behind the faucet. Okay, so check valve, it's a one-way preventer, so water doesn't go both directions, so there's an arrow on that one. A ball drip valve keeps from freezing, so if it goes outside, it's got a drip valve to make sure it doesn't go outside the freezing temperatures. 4 types of systems out there: wet pipe, dry pipe, pre-action, and deluge. Okay, so write those, circle those. Those are going to be on test stuff somewhere. We will get to that. I think we only have 2 Howell folks here, so you guys can take off. Howell folks can leave. Wet pipe systems are the most common. What we have up here is a wet pipe system. It's what most office buildings have. 90-some% of the systems out there are going to be wet pipe systems. The code requires them to have a sprinkler system, but then the occupancy use determines what type of system it's going to be. Most are wet pipe systems, because how many of us really have that much cold temperature, below 40 degrees, that we have to deal with? Your refrigerator, your freezer, that kind of stuff. Now, outside parking garages, that's a different story. Cold storage, where they ship your milk and butter and ice cream from, those are different stories. Those would not have a wet pipe system. Those need one of the other 3 systems that are a little bit more specialized. So wet pipe systems, where there's not freezing temperatures above 40, it's the simplest type out there. Requires little maintenance compared to the other 3. It contains water under pressure at all times. We know that. It connects to your water supply, and one sprinkler will activate as soon as heat gets it. If another one, if it's right in between 2, they may both operate at about the same time, but one does not affect the other. They are individual heat sensors. When one goes off, it goes off. Period, end of story. Has no effect on the other one. But again, you might have it where it's that spot right between the 2 of them where they're both going to get enough heat and they're both going to go off. And then you have 2 sprinkler heads. That's 95% fires, 1 sprinkler head, 98, 2. So to have more than that is very unusual. And then we'll talk about the other systems a little bit later. So questions on where we're at? All right, we will finish it up. Practical day tomorrow, so gear down. We'll finish this up on Thursday.